Hello everyone, this is MJS Pawan. In this video, we will be discussing previous year KSET Physical Science question paper. If you haven't subscribed to my channel, please subscribe to my channel and share with your friends. And if you haven't watched the previous videos, please watch the previous videos where I have solved the remaining problems, that is the beginning problems. Now, let's begin our starting problem. Question number 11. The equation of motion for a bead sliding on an uniform rotating wire in a force-free space. Okay, what is they are given? We need to find the equation of the motion. What a wire is rotating in a uniform frame. Suppose let's consider this as a wire and this end let it be fixed, and we'll consider this as an axis, and they have given an uniform rotating frame, force-free space. Force-free space means then in this case the potential becomes 0. Now what does it is moving? It is rotating. Okay, the bead is it is rotating at some fixed axis, and this represent an cyclic coordinate. This represent an cylindrical coordinate system. So we will write how one can write the Lagrangian L is equal to T minus V. So first we need to find the value of T. T is equal to half m, that is the mass of the bead, and x dot square plus y dot square plus z dot square. Since it is in a cylindrical coordinate, x is equal to this distance from the fixed axis is r, so this becomes r cos phi, and y becomes r sin phi, and z becomes z. Now find the x dot and y dot. X dot is equal to r dot cos phi minus r sin phi dot. Y dot becomes y dot is equal to r dot sin phi plus r cos phi dot. Now find the x dot square, and r dot square cos phi minus r square plus, okay, test I will write directly, sin phi into phi dot square minus 2r dot r phi dot cos phi sin phi. Similarly, y dot is equal to y dot square becomes r dot square sin square phi plus r square cos square phi dot square plus 2r dot r cos phi sin phi cos phi. Now we need to find the z dot. Since z dot is fixed, so there is no change in the z dot, so this becomes 0. Z dot will be constant. Now let's write the t value. T is equal to half m x dot square. After solving you get r dot square plus r square phi dot square. The phi is angular velocity, that is omega into t. When you differentiate, you get omega with respect to t. When you differentiate with respect to t, we get phi dot is equal to omega. Now substitute this 1 by 2 m r dot square plus r square omega square. Since it is a free space, so v is equal to 0. The Lagrangian L is equal to t minus v. L is equal to t. What is the t? 1 by 2 m r dot square r square omega square. Now find the equation of motion. D by dt of dl by dr minus dou l by, this is dou l by dou r, dou l by dou r is equal to 0. D by dt of dou l by dou r dot will give 1 by 2 m into 2 r dot minus dl by dr is equal to 2 r omega square is equal to 0. Again differentiate with respect to t, we get m r double dot minus 2, there is m term here also, minus 2 m r omega square is equal to 0. Taking m common out and multiplying this side, we get r double dot minus r second. Yeah, there is 2 get cancelled here also, so there is no 2 term here. R omega square is equal to 0. R double dot is equal to r omega square. This is the equation of the motion. The correct option is here is A. Thank you for watching. Please do like and subscribe to my channel. See you in next video.